Let's try it again. Hi. Statistics becomes useful when we can make decisions. And the first set of decisions we can start making right now is like the example we had last week about where is the borderline weight, how to separate the heaviest and the lightest people in a population, right? But that's not only, we can start designing things, right? We can start designing things. How many of you try to reach the radio or the AC in your car and never had a problem with it? Right, you reach it while you're driving, you don't have to move. Yeah, right here, right? But also, this has distance, right? If you look at the phones, the really big phones, there's no way you can swipe the whole thing. Like your hands aren't big enough, right? So you start talking about ergonomics, right? One of the common problems is trying to switch radio. I'm 6'4". My hands are so long I can, drive, eat a hamburger, talk on the phone, and still reach into the glove compartment, no problem. My partner, she's 5 foot, right? She rocks the seat all the way up, right? And if you want to push the little blinker, emergency blinker signs to say thank you that somebody let you, in the queue, for her, that's a whole movement to the side. I just go this, she goes this, right? So the cars are designed with this in mind. Phones are designed with this in mind. And you can start talking about it. So if we take a look at a simple example. No, we are still at chapter 3.
Oh.
Yes. We are talking about grip reach. And what grip reach is how far without moving your body can you actually reach. Right? The idea behind it is well, when we are talking about grip reach, we have to talk about reasonable examples. Right? And you have the little AC button right here, right? The T Rex is not getting anywhere. So this is what we are talking about grip reach is. Can we reach things?
What reach?
Exactly. Right. So we know that the grip reach for women is normally distributed. We know that the mean is 27 inches with a standard deviation of 1.3 inches. We did some measurements and this is what we're coming up with. So far so good. So we want to design a car with a console that is easily reachable. The grip reach for women is normally distributed. The mean is 27, the standard deviation is 1.3. So we want to design a car, right, with a comfortable console to be reached for. Now, are we worried about the people that have the very long arms? We are not worried about it because they will reach regardless. We are worried where the cutoff is on the bottom, right? And how many people are we willing to cut off before we start talking about protests, right? I tell you, you cannot come to school because your skin is too dark, right? It's a couple shades too dark. That's a big problem, right? Same with cars. If I design the car for people that have super long arms, that's going to be very, very awkward. So what we are trying to do is we're trying to limit the amount of customers we're going to disillusion by providing a longer distances. So find the value that represents the longest 95% of women. And by women I mean the grip reach. All right, I'm going to take off my mother-in-law on the board. Yeah, but considering I'm not married, I think I'm going to be okay for a couple of years. And so the question is, right, how do we approach? Well, we had two modes of operation, right? The first one was, hey, we're going to take a value, we're going to find the z-score for that value, right? And then from that, we're going to locate probability or area, right? Because those were the same thing. The second mode, which one? Find the value that represents the longest 95% of women. And this little here is, I'm not talking about women in general, I'm talking about their reach ability. Second thing that I introduced you to last week was, if we had probability or area, we could get the z-score from this. And then the last thing we did on Wednesday, we said, hey, we have a z-score, we can get back to the value. Right? We had those two ways to go about it, one way or the other. Right? Value z-score probability or probability z-score value. If we look at this example, we have a mean, standard deviation, and we have a probability, right? Represents an area. We know that area is probability, right? Because we use standard normal distribution. So first step first, artistic solutions. And now question is, where's the 95%?
27. No, 27 is 50, right?
27 is the middle, right? Because that's the mean. Now why they put it at 0 versus 27?
Oh, it's the
Because this is standard normal.
deviation, right?
Standard deviation is 1.3.
Was everything in
Longest 95%, right? This is the trick part of this problem. This is the difficult part of the problem. So we are looking for the longest 95%. So what's on this scale? On this scale is values representing the length of arms, right? So we would imply that this is short and this is long, right?
Oh, we need to cover all this.
All this or all this? All that, exactly. Right, we are going from the longest. We don't care about the super long arms because they're going to reach anyways. We're going to worry about here. So this is the 95%. If this is 95%, how big is this little piece? That little piece is 0.05. Okay. So what I'm interested in is this z value, right, the z-score. So how do we get the z-score? Does everybody have a table?
So it's x
Yes.
minus
So we're trying to find 0.05 in the meaty part of the table. Earlier, I think you have it earlier. Yep. You know, I've been teaching for a while and I can just look how many pages you flipped and tell you that you're on the right page or wrong. Right? So we look at here and we're trying to find 0.05. Well, if we look very carefully, we're going to find it at z equal to what? It's negative, yes. It's below 0. 4 or 5. Right? It's one of those three magical numbers we're going to use a lot. So negative 1.645. Is everybody comfortable how they got this?
No.
we were.
Yeah, I'm trying to look.
So we're looking for 0.05 in here. If we look for 0.05 in here, we're going to find it right here.
Looking at 0.005. I don't know what I said.
That's the problem with notations between tables and I try to always put 0 point something. I very rarely go point something else. So. You found it?
Could we not do the negative 1.604?
Yeah.
Because that's 0.0505. So could we go like in between the two?
Yes, because
Okay.
so this is the 1.64
Yeah.
for 5. This is one of those three numbers that we're going to use a lot. Those three numbers are 1.645, 1.960, and 2.575. All the other ones we're going to estimate to the closest of our ability, but those three
Right.
are special because those refer to very specific percentages. All right, did we find it? Yes? Everybody good? Okay. So now comes the, so we have the z-score, now we need to find the value. We remember from Wednesday, right, that the value equals to mu plus z times sigma. So the value equals to 27 plus negative 1.645 times 1.3. So x comes out to be 24.86. And the answer is, women with at least 24.86 inches of grip reach, right, are going to reach everything on the console. Or by keeping everything within 24.86 inches, only 5% of women won't be able to reach it. Right, because this refers to, hey, this separates the 5% of the shortest hands, right, or being, colloquial, if you cannot reach beyond 24.86 inches, you're a shorty. And maybe the truck is not for you. And I expect there's 5% of people like that, based on this. Right? This is what we can do. We can help design things based on this, right? Same thing happens with traffic, same thing happens with water maintenance, pollution, right? We know what the standards are, we know how much of it we want to remove. And this gives us a border to approach. Okay.